Hi everybody. So in this video, we're going to solve problems involving the arc length and the area of a sector. So we'll work through 4 examples, and if you want to work along with me, you can download this PDF from my website. I'll leave a link below. So I showed you in a previous video that when you've got a sector of radius r and angle theta, then the arc length L is a fraction of a full circle, and the fraction is the angle theta over 360 times the circumference of a full circle, 2 pi r. And the area is the same fraction of the area of the entire circle, which is pi r squared. So as we progress through this video, we'll be using each of these equations, okay? In example 1, we're given a sector of radius 12 centimeters and an unknown angle. We're told its arc length is 20 pi, so that's the length from A to B. I'll label this on the diagram as 20 pi. We need to work out its area. So if we're given this arc length, then we're going to use this equation, and we'll substitute 20 pi into here. So we've got 20 pi will equal the angle theta over 360 degrees multiplied by 2 pi r, and the radius we're given is 12. So our approach will be to work out the angle theta from this information, and then use this angle theta, we'll substitute it into this equation, and then we'll have enough to work out the area. So we need to begin by working out theta. Well, the first thing we can do is we can divide both sides by pi, and we know that 2 times 12 is 24. So we'll have 20 will equal theta over 360 times the 24. And 24 is a factor of 360. So we can simplify this fraction. We'll divide both by 24. So 20 will be theta over 15. And then we can move this 15 to the left-hand side. We'll multiply both sides by the 15. So 300 will equal theta. So we can see that this angle here is 300 degrees. Okay? And now we can work out the area. The area will be the angle 300 out of the entire circle 360 multiplied by pi and the radius squared, which is 144. Now we can simplify this fraction. We'll divide both by 10, these zeros will go, and then we can divide the 30 and the 36 by 6. So the area will be 5 over 6 times pi times 144. And 6 is a factor of 144. So now we can divide both by 6. So we get the area will be 5 pi times the 24. And when you work out 5 times 24, we get the area as 120 pi centimeters squared. Okay? So the key to this question was realizing we need to use this clue to work out the angle, and then we have enough information to find the area. Let's try example 2. So in example 2, we're given the area of a sector is 8 centimeters squared, and we're given the angle theta as 120. We need to work out this radius. So perhaps you want to give this question a go. You can pause the video and come back when you're ready. Okay, so how did you get on with that? Because we've been given the area, we're going to use this equation. So we'll substitute in the 8. This will be the angle theta, so 120, over the 360 times pi times the radius squared. And then we can simplify this fraction as 1/3. So 8 will equal pi r squared over 3. And then we can move this 3 to the left-hand side. We'll multiply both sides by 3. and we get 24 is pi r squared. And because we want to work out the radius, we'll divide both sides by pi. So 24 over pi will be the radius squared. And then we can take the square root. We don't need to consider the negative because we know it's a length and it has to be positive. So the radius will be the square root of 24 over pi. Okay? How did you get on with that? Let's try example 3. So now we're given the area of a sector is 40 pi centimeters squared. We're given the radius, but we're not given the angle. And we need to work out the perimeter. So again, do you want to give this question a go yourself? You can come back when you're ready. Okay, so how did you get on with that? If we label the angle theta, we know the area is 40 pi. And this is equal to the angle divided by 360 multiplied by pi times the radius squared. So times 100. We can simplify this. We'll divide both by 10 pi. So we'll get 4 will equal 10 theta over 360. And then I can simplify this again. We'll divide both by 10. So now we've got 4 will equal theta over 36. And then we can move this 36 over to the left-hand side. And we get 144 equals theta. So this is the angle of our sector. So now to work out the perimeter, well, we need to begin by working out the arc length. So L will be 144 divided by 360 multiplied by the circumference. So 2 pi r. We can simplify this as 144 over 360 times 20 pi. If we divide both by 20, then these will go, and we'll get the arc length as 144 over 18 pi. And 18 is a factor of 144. So we get the arc length is 8 pi. I'll label this on the diagram. So now the perimeter will be the arc length plus the 2 radii. And this is in centimeters. So we know that A is equal to 8 and B is equal to 20. Okay? Let's try one more question. So for our final question, we're given the sector with a radius of 8 centimeters and an arc length of 2 pi. We need to find the area in terms of pi. So if you want to give this question a go, you can come back when you're ready. Okay, so because we're given this arc length, we'll use L. So 2 pi will equal theta, which we're calling W, over 360 times 2 pi r. Now we can see that this 2 pi will cancel with this 2 pi. So we've got 1 will equal the angle W multiplied by the radius of 8 over 360. And 8 is a factor of 360, so this will simplify and we'll get 1 will equal W over 45. So the angle W will be 45 degrees. And then we can substitute this into the area of a sector. So this will give us 45 over 360 times pi times the radius squared, which is 64. We can simplify this fraction as 1/8. So we'll get the area as 64 pi over 8. We can work this out and we get the area is equal to 8 pi centimeters squared. Okay? Well, thank you very much for watching. I hope that's given you an idea on how to solve problems with sectors. If you did find it helpful, please like and subscribe, and you can download the full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.